efforts along the Upper San Pedro. I'm going to try to give kind of a general overview for folks that might not be that familiar with these projects. I know some of you are very familiar, so bear with me, but I'm going to try to kind of just give a broad brush to the projects and kind of touch some of the challenges of water management as kind of framing those challenges up front, talking about some of the supporting science that has been really instrumental in informing our projects and some of the decisions related to water management. And these projects occur along about 25 miles of the Upper San Pedro. A lot of the science that I'm going to be talking about today has been a collaborative effort and has been developed over the past 2 decades, really, through the support of the Upper San Pedro Partnership. And for those of you that aren't that familiar, I think maybe everybody on the call is, but it's a consortium of about 22 private and public entities that's been working together to develop some of these tools for water management through their technical committee. Additional technical analyses will be presented today that has also been prepared by private contractors to the Conservancy or others, and I'll try to note that and make that distinguishing that clarity for you as to what's kind of foundational science versus contracted work. The proposed suite of aquifer recharge projects that we're going to be talking about that are now under development are being designed and managed by the Cochise Conservation and Recharge Network. So during the overview that I'm going to give today, just to kind of help you anticipate what we'll be talking about, the first thing will be the water management challenge in a very kind of broad sense. Then we'll just give some highlights as to the science and how that's helped to inform some of the options we're going to be discussing. We're going to talk about the Cochise Conservation and Recharge Network efforts to design and implement recharge projects with some specific groundwater modeling scenarios that have just very recently been run with an updated groundwater model. And then just closing with the status of these projects and their implementation. So I'll stop there for just a second. Any questions? And I guess I very much would like for this to be an interactive conversation. So just to be clear, we can do that through either the little chat box, or you can stop me any way you want. When you have a question, just let me know how you'd best like to do that, Thais.
Yeah, I think enough people might be on the phone. Just, holler out if you have a question for Holly. If you've got this open on your computer, you'll see a chat box down below. If it's not fully open, just click on chat and you'll see a thing there, and you can select to only send your question to Holly, or if you send it to everyone, then we'll all see what your question is. And I think Karen Fogus has managed to join us.
Yep.
Hi. Is Kathy with you by any chance?
I had some difficulty with the number. It just wouldn't go through. So.
Yeah. Well, glad to have you on board. We just kicked off. Has anybody else joined?
Yes, Bill here.
Oh, welcome, Bill. Great. Have you got it on the computer or strictly?
Well, I have the PowerPoint and then I have it on the phone.
Perfect. Okay. Let's take it away.
Very good. And if for some reason I missed your questions on the chat box, just please speak up as we go through this. So just the opening slide is actually a picture of the Palominas Flood Control and Stormwater Recharge Project. And it was constructed in 2014. This is a picture of it shortly after construction. It looked kind of like this yesterday. We had some great rains here in the Palominas area. So just thought I'd kind of start with an opening shot of one of the projects that's in the network of projects. Okay, so then Thais, you have to help me figure out why my computer is not going forward.
Oh. Well, you've got
control. While you're doing that, can you tell us where is this in Palominas?
This is actually at the intersection of Palominas Road and Highway 92. There's a small school right next to it, right at that intersection. So it's on a tract of land that was that is actually called it was a proposed development project in that area that was bought by the Nature Conservancy and then conveyed to the county.
Yeah, the school is on the northwest corner. So where is this from the school?
Yeah, it's just due north of the school, and I'll have a map during the presentation that will show all the project locations for you. Yeah. Great. So just trying to kind of frame the challenge, and I know this is, again, something not new probably to anyone on the phone, but just to kind of get on the same page, the ecological needs of riparian ecosystems along the San Pedro are very similar to those throughout the West. These ecosystems depend on actually 3 different aspects of hydrology. They require shallow groundwater available within the floodplain near the stream. They also, usually base flows in the river are very indicative of those groundwater elevations. So those 2 things are very closely linked. And then on top of that, periodic flood flows are super important for regenerating the ecosystem over the long term. So keeping those relatively natural flood flows intact is certainly something that's unfortunately very unique about the San Pedro today. A lot of our rivers, as you all know, in the West are no longer free flowing, and the San Pedro is really one of those. So it's very important to maintain those different aspects of hydrology, and certainly the cottonwood willow forests, that you might see some mature forests that persist along seasonally dry river channels. But in those areas, there's usually not the recruitment of young trees capable of really sustaining the ecosystem over the long time. So when groundwater levels drop, in many places, the first thing that will happen is you won't see the recruitment of young plants in the floodplain with a very diverse understory. And so these perennial reaches have an amazing habitat value, and as again, I'm sure you guys are aware, it's a major migratory corridor of hemispheric importance, really, every year. And it's the diversity of the floodplain habitats in terms of mesquite and secatone grasslands, as well as cottonwood willow gallery forest, that makes this such an important corridor for migration and habitat. Any questions about the diagram and just kind of showing that relationship between the groundwater and the base flows in the channel? Again, the base flows being a good indicator of those near stream groundwater levels. Okay, so that's kind of our challenge, is maintaining those aspects of the hydrologic regime. And as you know, there are, we've tried to understand basically how intact that hydrologic regime remains today. This is an interesting project that was begun back in 1999, which is we refer to as wet-dry mapping. And it's a citizen science project that occurs in the same weekend in June, the 3rd week in June, which is perceived to be kind of the lowest base flow time, right before the monsoons hit. And if you were to go out and look at the San Pedro with a GPS unit and basically map where the river flows or there's surface water present and where it's dry, you would get a wet-dry map like this. And you can see on the right, what we've done is we've taken the results of each year's monitoring effort and put them side by side. We've also straightened them out so that it's easier to look for spatial patterns. But you can see that starting in 99, this actually only goes through 2014, but you can see that there's some real consistency in the flow patterns of the base flows in the river. And actually, that longest blue reach that you see where those blue lines are the longest is the longest perennial reach on the entire San Pedro. And I say that because we do map the whole, as much as we can anyway, of the whole river system, including Mexico, all the way down to the Gila and its tributaries. So what we're only seeing here is the result of the wet-dry mapping within the San Pedro Riparian National Conservation Area. You'll also see I've introduced the names of some of those recharge projects, and they're shown in green, and then their names are in those ovals. And you can see that there are 6 of them, and that actually does show that Palominas project location. It doesn't show the road, so that's not very helpful. But that was one of the questions about that first slide. So there's 6 recharge projects that are now underway. I'll talk a little bit about how we located them, but you can kind of get a sense for their location relative to the continuity of base flow patterns in this shot. And certainly this wet-dry mapping was some of the initial information that we used in thinking about where flows need additional recharge and where we could improve the continuity of flows, and especially at this driest time of the year. So this we thought was the most meaningful indicator as an initial indicator of where we could work on flow enhancement. Any questions about this one? There's a lot of things going on in between all of the wet dry, we call it the barcode on the right, and then it's just the overview of the National Riparian Conservation Area, some general locations of the projects. Okay. So talking more about the science, obviously the wet-dry mapping was kind of an initial way to reach consensus as to the status of the base flows, particularly during the driest time of year. But the other thing that became a very important science need was this development of a regional groundwater model. And so the Upper San Pedro Partnership that formed in 1998 was really focused around the development of this tool. There had been kind of dueling models in the past and a lack of trust between different entities about different modeling efforts, and there wasn't always consistency in, you know, what the results were saying in the scenarios. And so this was an effort to try to get everybody around the table to build a model we could all believe in. And it took several years. There was a lot of data, empirical data collection that helped to inform the model and improve previous modeling efforts. But this is just a picture of the resulting publication that did come out, which was a real step forward to have a model that was basically built by a very diverse and collaborative effort of participants along the way. I mean, obviously it's a GS product, but it was a very engaging process for the Upper San Pedro Partnership. And Trish, sure, feel free to chime in. I know you were in the room for many, many of these years. So that model, though, had been published several years ago, and we felt as if we were going to use the model today for some of this decision-making about these recharge projects, that we would really like to see an update to the model. So we, meaning the Nature Conservancy, but as a member of the CCRN, that was our recommendation, that we try to get the model updated a little bit so that we could use it more effectively with some more recent data. And so we asked Laurel Locker, a hydrologic consultant who's been working on the San Pedro for many years, we asked her what are the most important things in your mind to update the model to make it most accurate today. And so these were the 5 things that she came up with. There had been the retirement of some ag pumping near Palominas because of the conservation easements that were put in place in that area, and also because of the establishment of the Sprinka, obviously, the Tenneco well. So some changes in ag pumping over time. I believe the Tenneco well changes were already in the original model, but not the newer conservation easements. And then an update on the Sierra Vista's effluent recharge efforts that had begun in 2003, and also the City of Bisbee's effluent recharge and Greenbrush Draw was added to the model, as well as the stormwater projects at both Palominas and Horseshoe Draw. And then another major component of the update was the pumping estimates, actual pumping estimates, including unmetered wells, and trying to use the most recent pumping data and well use estimates. And also there were some significant changes in the census data and the state population projections. So we tried to kind of put all that together to make a more useful and accurate model. Okay, so another interesting application of the regional groundwater model was the production of this capture map, which basically helps us understand the spatial kind of implications of groundwater management. And so intuitively, not every place that we pump or every place that we recharge has equal either impacts or benefits on flows. And, you know, I think anyone could guess that if you were to pump far away from the river, that might have less impact than right next to it. But the hydrogeology can be really complex. And so sometimes, you know, using the information that we had, that we collected to construct the model, and running the model to predict exactly where the best places were for recharge, which are also the worst places to pump, was really helpful information. So let me just kind of run you through what this illustration is telling us. This is taken out of a USGS publication. On the left, it shows you basically the blue areas are the areas where recharge efforts would have the most immediate impact on stream flows. And so where it's dark, so you see the scale on the left, the blue, the very darkest blue means that within 10 years, if you were to look at the left map, those areas in the blue, basically the darkest blue, 100% of the water that you recharged would express itself at the river in terms of flows and benefits. So that's where you get the most bang for your buck. But if you were to go out into those red areas, you could get somewhere between 10% or basically no benefit in flows within 10 years by recharging in those locations. So this, started to really get us thinking about how we manage water and where. And obviously, there's many different ways to think about water at this scale. And we know there's water budgets, which are kind of an overall kind of a checkbook accounting of how much water is taken out and how much water is taken in, just as a lump sum number for the whole basin. That's certainly very important in a different way. And we can talk about those differences, but this is actually kind of a new way on top of a water budget to think about things and to prioritize. And so you can see if you look at the 50-year map that you have a lot more of that dark blue area. In other words, 90 to 100% of the recharge in a much wider swath would make it to the river over 50 years as compared to 10. Now, this is really hard to describe, so I'm going to stop right there and see if there's questions. Okay.
Yeah, this is tight. Can you hear me?
Yeah.
I was curious about the 50 years. So by seeing more areas that are, I guess, showing recharge, is that what that's depicting, the 50-year map?
Yeah, it's not really showing recharge. It's saying if you recharged here, that percent of it would get to the river.
And it would result in more areas being wetted and suitable for recharge? I'm trying to understand right hand.
It would tell you how beneficial your recharge is at that location to the river at that time scale. Yep. Now, for example, over by Bisbee, you'll see way over on the right-hand corner, there's a little red arm going out there. That remains red, and that's actually the area where Bisbee's current, near where Bisbee's current effluent recharge efforts are. What that tells us is that at 10 years or 50 years, if you were to recharge in that little red arm, less than 10% of it will ever benefit flows in that time frame. Not ever, I'm sorry. In that time frame, only 10% of that is really going to help flows because it's so far away from the river. If you recharge that same water way closer to the river in the blue zone, 90 to 100% of it would actually help benefit flows in a 50-year time frame.
Holly, this is Tricia.
Mm-hmm.
Yeah, it's you flipped the colors from the leak diagram, which makes it, I think, intuitively harder to grasp.
And there are two different diagrams. There's the pumping one, and then there's the recharge one, which is why they could go either way, right?
Well, and you're calling this the capture map, and so the capture map means something. Maybe you should call it the recharge prediction map or something like that, because the capture,
exactly
to me,
right.
It's flipped. Okay, but it's flipped from the capture map. And so I was having a lot of trouble with this, and I went and found the publication. And so, yeah, you flipped the colors and the numbers, and okay.
Well, I got this from Leak, so I'm not sure, I think there's both maybe in that publication, but you raise a very good point in that it technically is called a capture map, that's the tool, but it's showing the benefits of recharge, not the impacts of pumping, which is the other map that's opposite, basically. What you can take from this map without getting folks too confused about it is that there are certain areas where either pumping or recharge has much quicker impacts on flows. And so the very places that benefit the most from recharge are the same places that will also have the biggest pumping impacts. And it is, at least on this map, it's only showing where recharge, the benefits of recharge are in the blue, the best effects in terms of recharge, if you want that to express itself in the river, is in the blue zone. So we can think about this more if you want. This one's a brain twister. This is probably like the hardest illustration of the whole presentation. So tell me if you want me to move on or go deeper.
At the risk of really creating chaos, is the persistent red up near the Baba Kamari in Charleston, is that the location of the Sierra Vista wells?
Yes.
Okay.
Which, frankly, is good news that it takes longer to get to the river. I mean, if there was a big, but again, this isn't the pumping map, this is the recharge map, so it does get rather complicated. But what it does tell you is that where the words Sierra Vista are, it takes a long time for the implications to hit flows in the river from that location, which is a long time relatively, not for, you know, so that is good.
Logically, right.
Yeah. Yeah. Okay, well, I'm going to move on from this. This is a tricky one. And again, I don't want to get you guys too much into the grimy details, other than to say that we do know that pumping from any given location doesn't have the same effect on the river, nor does recharge at any given location. So we've tried to place the recharge in the places that do the most good. And I'll talk about that more as we go. Moving on to the Cochise Conservation and Recharge Network, you may have heard the acronym CCRN. And I just wanted to talk about them just really quickly. It's different from the Upper San Pedro Partnership. It's here's a listing of the members at the bottom. It's the cities of Sierra Vista and Bisbee, Cochise County, the Hereford Natural Resource Conservation District, and the Nature Conservancy. And what it is obviously their purpose is to implement regional water management projects that meet the long-term water needs. But what I really wanted to emphasize here is that it is a project implementation group. So the entities listed there either own these projects, or in our case, we bought the land and then flipped it to the county. And so it's the actual project implementation group. This is very different than the partnership, which has, you know, fostered a lot of good science and had all kinds of different roles over the years. This is a much narrower kind of function of this group, is to implement these projects. But their vision is somewhat still aligned with the Upper San Pedro Partnership, and that is for a flowing river, the conservation of water resources, and a viable local economy. That group of players has a technical work group that oversees the implementation and design of these projects, and it includes the staff from the county, the city, and the conservancy, along with a suite of consultants. Many of these consultants are the same consultants that have been working with the Upper San Pedro Partnership over the years. And then in addition to that, there's also agency partners, including ARS and the USGS, that have been providing additional project monitoring support for the recharge project. They're really key entities because a lot of what we're doing is based on simulations and modeling. And as you guys all know, no model's perfect. So we are very clear that we want the performance of any of these projects to be monitored over time. We'll talk about that monitoring more as we go here. The other thing that's been very important, and this really is something that the Nature Conservancy has tried to promote, is that there's this exchange between the Upper San Pedro Partnership and the CCRN members in terms of scientific and technical review for these projects. So this is just a listing of some of the technical work that has been discussed and reviewed and presented to the Upper San Pedro Partnership. And I won't go through it all, but everything from kind of the investigations to design different recharge structures to just understanding the rainfall and runoff relationships and the presence of stormwater that might be available, quantifying that stormwater that might be available for recharge. And so anyway, it's just saying that I think it's really important to have that technical horsepower, if you will, with the Upper San Pedro Partnership to interact with this project implementation group. Okay, so let's get into some of the more recent modeling scenarios using the groundwater model that were conducted by Laurel Locker. And these were at the request of the Nature Conservancy to try to understand how these recharge projects could work with one another along 25 miles of the river to enhance flows, and how we might best design them. And so one of the questions that came up early was we compared two recharge scenarios. And it's basically, what if we design this recharge network to the extent that we think, full build out that is reasonable could occur, versus we didn't do these recharge projects. What's basically, so we're calling those two scenarios, one's max CCRN recharge and the other's no CCRN recharge. It's like, tell us what we get by implementing these projects together. And so we had to make a whole lot of assumptions about what that would look like in terms of what water would be available in any one of the projects. And that's what you'll see. The recharge rate here was just basically a proposal for trying to get that amount of recharge up and running at these different sites. And you'll see that there's the year on and year off. So some of these projects don't always start on the first year. It was kind of what we thought was kind of a staggered but realistic time frame for starting the project. And in the case of the no CCRN recharge, there's obviously some projects like the Sierra Vista Environmental Operations Park is the EOP basins. Those are already under operation. But frankly, what if they turned off in the year 2023 when their agreement with BOR ends? What does that look like for the river? So any questions about, this is basically the question that we're asking the model is, with and without recharge, making all these assumptions on these projects, what's the difference? Any questions about the scenarios?
So just double checking.
Yes, at some point, are you going to talk about the source of the recharge or sources?
Yes.
Okay.
Yeah, we can certainly do that. And I'm sorry, I'm realizing that I also have some chat things that I had paid attention to as I was talking here.
Holly, I sent in a question.
Just let me finish that one last question about the source before we move on, because we can be very specific about that. But what I would like to say at this point is that it's assumed that the sources for recharge water are either treated effluent or urban runoff, which is basically that amount of stormwater runoff which is due to urbanization. So this is like the extra runoff from developed areas, which we have tools to try to quantify. And that's what those numbers are in terms of the recharge rates. And they do make some assumptions about build out and all those things.
Yeah, but Holly, well, I mean, depending on what shows up on your simulation, I don't think your 2023 to 2075 number is fair, I guess. I typed my message.
Yeah, okay, I was just trying to catch up on your message. So so you're saying that the no recharge number is not fair?
Yeah, I mean, it's not like that 28 or whatever it is, the 2,300 acre feet from the city's EOP. It's not going to not occur. It might change location, but it's not going to not be available for your simulation. So that's
true, and
unfair or unrealistic or whatever in terms of showing how drastic your difference is between those numbers, I guess. But maybe it'll work out as you work through the slides.
Yeah, well, and I will say it's very hard to predict if the city was not willing to recharge that effluent at their existing facility, which is relatively near stream. Where would they? Would they reuse it, or would they recharge it somewhere else? I guess the underlying assumption in this scenario is that if they were to go through the effort of not using that expensive recharge facility near the river, it would probably be out in that red zone of the capture map, which wouldn't have flow implications for 50 years or more. So that was just an assumption, and you're right. We don't know what else they would do with it, but we were just making the assumption that if they turned off EOP, given the cost of that infrastructure, it would probably be much farther from the river. So hard to say what they would do, and we had to just kind of draw that conclusion. Was there another question?
Yeah, this is Tice, and I guess a follow-up on what Tricia just discussed. The EOP has been a recharge element to the river for as long as I can recall. Is there some embedded assumption that the city, by being a member of the CCRN, would make a, commitment, legal commitment to maintain those recharge numbers through the EOP or any kind of a redesigned water treatment facility?
That's what the Nature Conservancy hopes, and it's of frankly very big concern, and you'll see this later in the slideshow, is that the volume of EOP's effluent, it makes complete sense, being the largest city in the watershed and the largest source of water. I mean, it's without the EOP, this whole package doesn't work, and it's a major component of this package. And so their commitment to continue that near stream recharge, like I mentioned, was tied to funding that came through the Bureau of Reclamation when they constructed the facility, and those obligations expire in 2023, and there is no promise legally that they will continue to do that. And so I don't know what they will do, Tice, but I think it's important for people to understand that if they don't continue the near stream recharge, what are the ramifications? Now, we could have done a modeling scenario where it's just EOP on, EOP off, not the suite of projects. But again, it's the biggest source of water of any of the projects, so it's very meaningful. And there's no reason that they have to continue to do what they're doing at the time that I know of. Okay. Anything else? Okay. And again, if you were to think about it, just a bottom line water budget, it doesn't matter where EOP reaches, right? The water budget looks the same either way. But in terms of actual flows at the river and the timing that it takes for that water to help support flows, it makes a really big difference. Okay. So this actually shows just graphically the scenario that we run, and it shows just the relative difference in the volume of water for each project. So that gold line that's really small in the foreground is the Palominas Stormwater Recharge Project. A very small amount of water recharged there. The Horseshoe Draw, that actually, if you look at the initial years of the Horseshoe Draw project, it's a small blue line that's kind of like the Palominas project, but then it jumps up into this larger block that has green stripes. The green stripes are making the assumption that Bisbee's effluent might be available for recharge at that location, and that's why that source water increases for that facility. And then if you were to keep going, the next one is Riverstone. Riverstone starts out with no source water and then incrementally grows over time, and that would assume that there is additional development nearby that has effluent available and stormwater. but that there are no promises, there are no obligations, and that was just a scenario that we wanted to look at in terms of, again, the max recharge scenario that we could conceive. The Bella Vista has that kind of orange bar in terms of its source water, and that's based on the estimates of stormwater runoff from downtown kind of urban Sierra Vista that goes through Coyote Wash to the Bella Vista site. And that's in the neighborhood of 600 acre feet, we believe, of extra urban enhanced runoff that might be available for recharge there. But the bottom line of this illustration is that huge blue wall in the back, which is EOP, and that just gives you the relative volume of potential water that we could see available. All of it is small compared to EOP. But the thing that's important is it's not just the total number of acre feet recharged, it's where it's recharged. So the value of those smaller bars is that they are located in upstream locations that have fragmented flow. It goes back to that wet-dry map. Where is the river fragmenting? And particularly right near the international border, we see a lot of fragmentation. So for example, the Bisbee effluent would be very important if we care about that reach. Next, what I'd like to do is just go through the results of the model, and they're portrayed in a couple of different ways. The first way that the model results are portrayed is at the stream gauges. So it basically shows the difference in simulated base flow with and without the network. And so you can see the no CCRN is the orange dots, the CCRN max recharge scenario is the blue line. There is a difference between those two lines, although the trends are similar. So this is an important thing to talk about and to acknowledge. This is not a solution to the problem forever. This does not mean that at this gauge that base flows will be entirely improving or even stable. But what it does say is that out at the end of this time frame in the year 2075, there is a 23% improvement even then in flows versus not doing the projects. So the trend is similar, but the line is at a, there's a space there between in benefit, and that's the quantification at this gauge, which is, as you know, right at the Mexico border. So, and again, this assumes that the EOP turns off in the no CCRN scenario at 2023, and that's what that vertical black line shows. So compare the Palominas gauging station and the way that it responds to recharge to Lewis Springs. And there's a different slope to the line. The Lewis Spring line here actually becomes more stable, and you don't see the same trend. There's only a 16% difference in 2075. But it's certainly the line flattens out, and it is a different response than we've seen in Palominas. And then if you were to go even farther downstream and look at the Charleston gauge, we actually see the biggest difference there, and it's a whopping 82% by the year 2075. And frankly, that relates to the fact, again, thinking about our biggest source of water being nearest to the Charleston gauge, the EOP difference here is pretty significant. That project makes a big difference in flows as far out as 2075. And the line gets a lot flatter. So it's just interesting to see how different points of the river respond differently to this kind of package of projects. If you were basically looking at it as we did in this scenario, as if you could really secure those water sources, kind of the max scenario CRN projects. Now, I want to look at it in a different lens. This is looking at a map instead of at stream gauges of how the base flow would change. At first, we're just going to look at a shorter period here from 2003 to 2025. And again, we have the no CCRN recharge on the left. We have the max CCRN recharge in the middle. We've also, though, thrown in an additional thing to the package was what if we reduced Mexico pumping by 2,000 acre feet on top of the max CCRN recharge? So one of the things that I did want to bring to your attention is that the Cochise Conservation and Recharge Network has both conservation and recharge in its name. And even though most of the conversation has been about recharge, there are also different options for conservation measures being discussed, and this is certainly one of them. Is there a way, either through ag efficiency projects or maybe potentially working with the mining industry in Mexico, that we could reduce near stream pumping there? And would that really extend and enhance those benefits of recharge? And what we saw was actually pretty surprising. And frankly, you know, it's hard to make the case to do the recharge projects if the pumping upstream is going to completely erase those benefits. And that was one of our questions, is, you know, kind of due diligence on these investments and these projects. So just to explain what we're actually seeing here, and again, it's pretty complex in terms of what these colors mean, but it's looking at the change in base flow. It's not looking at absolute, it's looking at the change in base flow. So, and that change, basically, the blue is where you're seeing improvements in flow over this time period, whereas the red is where you're seeing decreasing flow. If it's white, that means it's basically a zero, it's a neutral compared to 2003. So the no CCRN recharge, even by 2025, you can see there's still some spotty blue near the EOP, where those benefits of recharge are likely still expressing themselves even at 2025, even when EOP is turned off a couple years before that. You can see some real decline on the Baba Kamari. But comparing that with the CCRN recharge at 2025, you see much more increase in flow. But then the thing that's also very interesting is that you don't see a lot of difference between the max CCRN recharge and when you combine that recharge with reduced Mexico pumping. And that was a real surprise. So I'm just going to run to the next illustration unless there's questions on this. There's another one that's kind of similar.
Ollie?
That's if we look out to 2050. So now we're comparing those changes over a longer time period. And you do see that the no CCRN recharge scenario has a redder, oranger look to it. So what that really means is that we're seeing a bigger decline in flows over the longer time period after the EOP has been turned off. You're still seeing a relatively strong improvement in flows, especially in the EOP reach. Some in Palominas. You also, though, see some declines still in Mexico in any of these scenarios. You don't necessarily see a big difference between the max CCRN recharge and even when you combine that with reduced pumping. Those things look fairly similar. The Baba Kamari is of concern because in all of these scenarios you do see decline. And of course, that makes a lot of sense given that there's no recharge efforts in that portion of the basin, which is of concern. Any questions about these illustrations? Okay. And it just goes to prove this is a very dynamic system. So we're not going to see the same response in different reaches of the river, but it's informative to get a handle on how the different reaches differ from one another, and then obviously at different time periods. This was another one that I thought was basically the third way to look at the modeling results over time. Because the Cottonwood riparian gallery is so dependent upon shallow groundwater elevations, one of my questions to Laura Locker was, well, you know, you've shown us the differences in base flows, and yes, base flows reflect groundwater elevations near the river very closely, as we talked about earlier in our conversation today. But can you also use the model to actually map out where that groundwater would improve or not? So, you know, what's that lens of looking at the groundwater change over time? And this is comparison here of basically where, and again, this is just change in what she calls head, and the difference in head means basically think of it as the difference in depth to groundwater. And she looked at this, the model has different layers. This is in model layer 1. And in 2050, and what she defines as riparian acres is acres within the SPRNCA, not all of which are necessarily forested habitats, but she tried to just count the number of acres within the riparian area where they are improved and compare that in different time periods. And so you can see that actually there's a continued improvement between 2050 and 2075 in groundwater head between those two. It continues to improve during those points in time. And even down in Palominas, the extent of that groundwater improvement continues to broaden over time. And remember that that southerly border area is where there is a lot of fragmentation. So, and then the bottom line is that, you know, the number of acres that benefit in terms of groundwater depth in the riparian area more than doubled between 2050 and 2075. Questions about this one? This is kind of the last lens of kind of how to look at the modeling results. So we looked at how it compares with the stream gauges. We looked at how it compares in terms of just the flow throughout the channel. And now we're looking at how it compares in terms of groundwater depth.
Holly, I'd like to go back and look at slide number 15 at some point. We can either do that at the end or we can do it now if we're going to leave this topic.
Sure. And you know, you're going to have to help me because I'm not sure I can see the numbers, but tell me what's on slide 15.
It's the Palominas gauge.
Okay. Right there.
And my observation here, and you can tell me if I'm wrong, but the implementation here is to make a ever worsening situation less worse. Is that accurate?
Mm-hmm. Yes.
So,
and so what that means is that this is, yeah. Sorry.
At the Palominas gauge, something according to the no CCRN dots suggests that flow is going to, in acre feet, is going to continue to decline from 2023 to 2070 something. And by implementing CCRN, it's just not going to decline as quickly. Is that accurate?
True. It is.
So where there's, you know, for example, at Route 82, where there's no flow last month, then there's going to be presumably a longer period of time for which there is no flow at that gauge, et cetera. Is that all accurate?
I think so. I mean, it depends on, you know, what time of year and the storm flows and a zillion other things. But in general, what I would say is that there's 23% more flow, but it's still less, you know, at 2075, but it's still less than we have today.
And is the reason for that the ever increasing demand on upstream flow?
You know, this is where the modeling gets hard because the causation is always hard to pinpoint. It's usually a combination of factors. And I would guess that, you know, the historic pumping in the Palominas area, it was kind of the heart of the historic agricultural pumping in the past. And some of that high volume pumping, those effects they're very, very lagged in their response. But you can't say it's just that. It's also likely withdrawal south of the border and the combination of those things, and possibly on top of that, drought and climate. And so when you put them together, as best as a model can do, the combined effects are these results. And I can't tell you how much of that is from historic pumping in Palominas or Mexico or drought, definitively.
No, but presumably the model inputs would reveal that.
Mm-hmm. Assumptions in the model have created this output, and those were the best assumptions that we had, even with the updates.
Thanks.
Mm-hmm. And again, I think, you know, it brings up this broader point for conversation, which is, no, the river is not all the problems are not solved. But it kind of broaches this hard question about, is it still prudent to take these measures given this amount of benefit? That's kind of the ultimate question. And it's a hard one. I'm going to go back to where we were, unless you guys have any other questions about any of these. I know it's a lot to think about. I'm throwing a lot of stuff your way. So here is a summary of just looking at it through those different lenses. Adding the CCRN max recharge results in significant benefits downstream of the projects. Now, that doesn't say that it improves conditions over current day or even maintains them, but it does provide benefits. The number of acres of riparian area with simulated groundwater level increases of a half foot or more, and we talked about those numbers before. Those are significant. And again, remember for the habitat itself that the groundwater levels in many ways are almost more important than the flows in the actual channel in terms of sustaining that forest, right? The forest really cares about the groundwater depth more than it cares about what's flowing in the channel, but the two are indicative of one another, and so both important. The second bullet is that the max recharge does increase simulated base flows in 2075 over basically no recharge by those amounts that we talked about. And then the last bullet, which was interesting, was, and frankly somewhat confounding other than it's a hydrogeology factor, is that 20,000 acre feet per year of pumping reduction in Mexico has no impact by 2075 on the simulated base flows in the upper San Pedro. It was rather surprising. But the confining layers in Mexico probably are part of why that happens. And I will also say that what we know about those confining layers is very sketchy. The hydrogeology is not as accurate down there as it is in the US in terms of the information that we have. So this is only our best guess. I wanted to close just kind of giving you a little bit of an update as to what's happening today on these projects, where we're at, what's their status and stage of implementation. Again, here's a better map finally with the roads showing the different project locations. The Horseshoe Draw on the lower right is on the Ladd Ranch. That's actually a conservation easement held by the Bureau of Land Management where those projects are located. Or I'm sorry, it's actually one project, it's Horseshoe Draw. There has been a stormwater component that was just recently constructed, but the proposal is that it may in fact someday also be the right location for recharging Bisbee's effluent as well. So there's actually kind of two Horseshoe Draw projects in the same location. One would be a stormwater and the other would be effluent. The Palominas project is shown right there on 92, exactly where we described it before. Just north of that is Three Canyons, and that one actually is not a recharge project, but was an irrigation retirement project for the largest agricultural irrigation that remained in this area. And so that one is really more about discontinuing high volume pumping than doing recharge. Going north is Riverstone. And one thing I might mention about the Palominas project, Riverstone, and Bella Vista is that they were all planned developments, some of which, like Palominas, had already been platted and were moving forward. When the market, the real estate market tanked a couple of years ago, all three of those properties were in bankruptcy, and that is when the Nature Conservancy purchased them using Department of Defense ACUB funding. And we did so under the understanding that even if no recharge occurred at those development sites, basically ensuring that there wasn't near stream pumping was a huge step in the right direction for them, because these were, you know, like Bella Vista is like 3,000 acres and Riverstone's like 1,800 acres. These were large developments. So I will just mention that again, even if no recharge occurs at any of these sites, the fact that pumping has been precluded in them in the future given their near stream location, is probably really important. Questions about the network? You can see that the Sierra Vista Environmental Operations Park is right next to Bella Vista. The mound of groundwater that has accumulated from their recharge extends almost completely under Bella Vista from what we know in terms of the well monitoring. So the Bella Vista actually protects a mound of groundwater that has been stored given that EOP project. Just to give you a sense of where project implementation is at these different sites, this is a really confusing graph. Don't worry about it other than it lists the different projects and just gives you a real rough estimate of what stage of implementation they're at. You can see, for example, that some of these things happened before 2015 when the CCRN actually formally kind of got together. Palominas was already underway, obviously, the EOP. The different colors relate to different parts of the project implementation. So in other words, the initial investigations in terms of hydrogeology is the blue bars. The kind of final site investigations and more detailed engineering are the green bars. The construction of facilities, the yellow, the pink bars are basically operation of recharge facilities when they become operational, and then the monitoring is the orange. So a couple of things I just wanted to say about this is one of the things that we've learned is that starting the monitoring before any project construction is really important in terms of establishing a baseline and being able to assess the actual performance of any of these projects. So we've tried to move that forward. And starting in 2016, you'll notice we ensured that every one of these had baseline monitoring started so we could be more accurate as to really projecting the difference of constructing the projects. You'll see that, again, Palominas and Sierra Vista EOP are the ones that are almost, entirely operational and under construction, whereas the Three Canyons, I mentioned that probably won't even have recharge facilities. That one really is just a pumping retirement project. Again, though, we're monitoring how that one might respond from ceasing pumping in that case. So really the active projects, the Horseshoe Draw Stormwater Project was constructed this summer. As of last night, it had 3 feet of water in it from a really intense rainstorm down here. The effluent project is not underway yet for Horseshoe Draw. Neither is Riverstone, and Bella Vista is just kind of in its initial and final investigation stage. So anyway, just to say there's multiple projects with a lot of things going on, and it's the project management of these different sites and the engineering work that the CCRN has been really the focus of the conversations, as well as, frankly, the transfer of these lands, which were several thousands of acres with conservation easements to the county, which was quite a big endeavor for the Nature Conservancy to undertake in the last several years. Questions about any of the project development stuff? And then just lastly, this is actually the definition of sustainable yield of groundwater, and just trying to find this balance between basically the development and use of groundwater in a way that can be maintained for an indefinite time without causing unacceptable environmental, economic, or social consequences. I think it's true that we're not there with these projects. It's obviously, we cannot maintain indefinitely the flows in the river nor its groundwater elevations, but I think it's an important step forward towards that goal. And I think that the clock is ticking, and that we don't have the luxury of not doing those things that provide benefit as quickly as we can, because the ecological side of this equation is not going to be able to withstand these things going down in their condition really quickly. And while we don't have all the answers, there are some things that we can do, and we should be doing the things that we can do, and we should be honest about their benefits, and we should also be quantifying the remaining challenges that we still need to address. Any other questions?
Yeah, Holly, I posted a question about, I think it was the next to last slide, or maybe 2 slides ago. I just want to be sure that, one more. What? No, must be one more. Yeah. Oh, here we are. That's it. Thank you. The second bullet has these increases of simulated base flow. And I wanted to be clear about what we're comparing to. So the 82% increase at Charleston, is that compared to the no CCRN numbers model run?
Yes, it is. And again, it has an embedded assumption that wherever EOP water goes, it's not going to interact with the river within this time frame.
Right. Yep. Okay. Just want to be clear. Thank you.
Yeah, yeah. Anything else? I will say I think we're very fortunate to have the amount of knowledge and tools and data that we have about this river. Very few basins that I know of have the ability to try to even get these kinds of predictions made, and they obviously may not be perfect, but they do give us some relative comparisons to make decisions on that I don't think a lot of places even have the benefit of. So I guess we are lucky in that respect. But on the flip side, I think we all know that while some of these numbers are encouraging, it's also not the end game, and that we're going to really need to work together and to continue to probably coordinate closer than ever to figure out what those other missing pieces are.
So, Holly, Tice here. Those properties, Riverstone and Bella Vista, have they been transferred to the county?
They have, and just so that you know, Tice, we bought them, like I said, when the market was at its low, thank goodness, because we would have never, ever gotten the funding with their previous values to purchase them. But we retained them for multiple years before we actually got the easements in place and the transfer, and they've only transferred in terms of, Palameus was the first to go, and thankfully that was kind of a smaller, easier project to do first. But the Riverstone and Bella Vista, which are the two really big parcels, did not transfer until the last year, and we've learned a lot. I mean, we've frankly never written a conservation easement that allows for aquifer recharge facilities to be built on them before. So part of what this whole CCRN process was trying to understand how to do this transfer. Very new for the Nature Conservancy in terms of the type of easement. Very new for Cochise County, who is not used to managing large tracts of land. So I think it actually was a big step forward in moving this along. And again, those easements do preclude high volume pumping forever on them. So that is a big step in the right direction.
How do smaller projects
also,
how do smaller projects like the Borderlands group work on the Baba Kamari figure into these calculations?
Yeah, it's harder to quantify some of those projects, definitely, but I do think that, for example, the Baba would be really ripe for expanding the conversation. Obviously, the modeling results show every scenario looking rather bleak for the flows in the Baba. So I guess one of the questions that would be very interesting to pursue is there some land protection along the Baba that could preclude pumping in bad places? And is there a way to work on some watershed type improvements in those areas, even if aquifer recharge is not possible now, but maybe making options for aquifer recharge possible there in the future as well? Because some of these land purchases are things that could provide opportunities decades from now that we can't even imagine, right? But if the lands aren't secured, the options to do things there or to preclude things there may not exist in the future. So I actually think that, you know, we've taken a first shot at this in addressing 25 miles of the main stem, but it is disheartening to see that, you know, right at the north end there, the Wawakamahari, which is a resource in its own right, hasn't been included. So.
Well, thank you very much. Does anybody have any closing questions for Holly?
Just from a process point of view, has the Upper San Pedro Partnership embraced CCRN?
I think that that's a question that different people would answer in different ways. What I will say is, from like the Conservancy's perspective, we tried to bring every piece of science that we thought was important back to the partnership for their input. But I will also say that it has been a small group of the agencies implementing these projects who have been having conversations without many of the members of the partnership, and it doesn't really feel good if you're not in the room and you don't understand what's happening. I wish we could have had more outreach to explain what we were doing throughout the process and more interaction and communication. My hope is that we can do that going forward. I would really like to see the technical committee of the partnership assume a really strong and active role in continuing to have conversations about the science relative to the projects. But I also can respect that the people implementing them, when they're talking about finances, engineering, and how they're going to operate a facility, you know, those might not be the conversations they want to have with 22 member agencies. That's kind of like their project, you know. So I think it's been a mixed bag in terms of, I don't think the communication has necessarily been as transparent as everyone would have liked, and yet I understand kind of why, but it has been a real challenge, and I think there's been probably a lot of misunderstandings because of it, which I am very sorry for in hindsight.
You broke up a little bit. Repeat.
Yeah, I was kind of rambling there. I don't know how long I broke up for. I was just saying that I do think that I think it's a mixed bag in terms of the interaction between the partnership and the CCRN, where the two groups have a very different focus and mission. The CCRN is the people implementing projects talking to each other about what they need to do next to basically do the project that they're working on. And those conversations have not been very transparent to the partnership. And on the one hand, I can understand why, because sometimes they're financial conversations or legal conversations about conservation easements or whatever in terms of, but it's always been about project implementation. And yet, you know, I think there hasn't been a lot of understanding that that's what the CCRN is working on, is project implementation. And so without very clear communication, I just think there's maybe been some assumptions and maybe even misunderstandings about what the CCRN is doing, because it has been a small group and it has not included all the members of the partnership. As a member of both, what the Conservancy has tried to do is make sure that all of the science being generated by the CCRN or its partners goes back to the partnership for review. I hope going forward that we can have more communication and understanding, common agreement, even about like these numbers. And I want you to know that we're making efforts now to schedule 2 different technical committee meetings to review exactly what I presented to you today. One of the meetings will be solely about the update to the groundwater model that Laurel worked on and going through those numbers in great detail with the technical committee. The next meeting will then be going through these scenarios and all the assumptions that went into them, as well as the results. So I hope that that's the kind of iteration that we can continue to do, so that there's a better understanding of what the CCRN is doing. And I will just close in saying that to build the remaining projects anywhere near that max CCRN scenario will take very significant funding that is currently not secured. And so one of the conversations which has been going on is there a way to basically get some local commitment to fund those projects as well as federal commitment? And that's an aspect that Peter Culp has been helping us with, and he has a lot of experience with kind of those types of agreements from his work on the binational on the Colorado River. And so I just wanted to mention that I think that that is the only way this will happen, is if basically both the local and federal interests can come together to fund these projects, because there is, just like there is no water secured for them legally right now, there is no funding secured for those remaining projects either, other than, you know, some that we have to work on Bella Vista for a while and things like that. But I just wanted to state that, you know, this is not like we already have the water and the money. Like, we completely don't. It's a work in progress, and it likely won't be possible without coordination, communication, and support from every level. And I hope that in a way makes people more comfortable that, you know, this can't happen unless there's broad support. I firmly believe that. And so I feel like we're kind of trying to catch up, frankly, on some of the communication on the vision for this and the science. And I hope we can do that in the coming months.
Follow up on Bill's question. Maybe Linda and Tricia can help on this. I am not aware of any formal proposal being put forward to the Upper San Pedro Partnership Advisory Committee for an up-down vote to support the recharge network. Is there a plan to do that?
I don't know, Ty. I don't think so, not to my knowledge. I feel like the partnership is at a place right now where even getting agreement just on the prioritization of individual projects in recent years has been tough, and there has been division on it. So I don't necessarily suspect that that's where anyone's thinking of going. I just don't know that there's that level of agreement in the partnership itself. But what I would hope is that, you know, individual member agencies can understand this proposal and this thinking and this science, and, you know, at least as individual entities, that there can be enough information that people can make their own judgment of its value. I see the Upper San Pedro Partnership, I hope, going forward as a hopefully maybe even more invigorated technical group that can share information, but the prioritization of spending money as a group hasn't been working. And I don't know that it's the right venue to do that, because I don't see that being, frankly, very doable. I think it's a better venue to have the conversation about the science, because we have some brilliant minds and it's a really great place to do peer review, not so much a great place to vote on the expenditure of funds.
Tice, whether or not it would be doable would, of course, be a question, but to my knowledge, there's been no proposal, of course, and may not be. Holly would be in a better position to know if there's even talk about bringing it to the partnership. But at this point, the answer would be no.
Yeah, I see nothing that suggests otherwise. What I am actively promoting, though, is that the science gets peer reviewed, because if there are any weaknesses or gaps or holes in the science, you know, I sure hope we can find out what those are. We are working with individual consultants who themselves would like that peer review. So I see an evolving role for the partnership being that, and getting away from talking about kind of the finance side. Just my perception, though. And
okay, thanks, Holly.
Given the history,
any further questions for Holly? All right. Thank you very much. This has been very helpful, and I will say this had a lot more material in it, Holly, than the one we saw before. So thank you.
Well, I wanted
Yes.
to get Laurel's most recent results in there, and I apologize for some of this stuff is so kind of dense, like the capture map. It's hard to run through quickly. So thank you for hanging with me.
Thank you, Holly. Tice, will there be a follow-on discussion within the Science and Policy Committee about this issue? Will you try to schedule something?
Yeah, I'm not sure who all was on the call today. Maybe you. Yes, I'll do some follow-up and see where we go with this next. Thanks.
Okay, great. Okay. Thank you, Holly. A lot of info.
Thank you, guys. Let me know if you have any